This video will help you review for the nomenclature portion of Exam 1. Before you begin, you should assemble a few materials. Your periodic table, the original one we received in class, as well as the goldenrod colored periodic table that will be used on tests. And on the back of that, remember, it has the overview of how to approach nomenclature. Let's start by taking a little bit of a look at that. As you approach the nomenclature portion of the test, remember that there are 4 distinct types of compounds to write and name. Organic, acids, molecular, and ionic. One of the things you could start with is, does it have carbons and hydrogens? And if so, then it would be an organic compound. An alkane, an alkene, an alkyne, an alcohol, or an organic acid. And remember, the first 4 prefixes for organic compounds are a little bit different than the traditional numerical ones. Meth, eth, prop, and bute represent 1, 2, 3, and 4 carbons. If it's not an organic compound, then I would look to see if it's an acid. If it starts with an H, the beginning of the formula, we would use the acid naming rules. The only thing to be careful of, if you take a look at this portion over on the right, is it labeled pure or gas? Acids, when we talked about them in class, we said that they are solutions of a compound that has a pH below 7. So there have been in the past a situation on the test where we had both HCl labeled AQ and HCl labeled either pure or gas. All the compounds we've been naming in class that start with an H, we've assumed to be aqueous solutions. So if it's labeled with an AQ, then you could assume it was an acid, and you would use those acid naming rules. I'd hide Rick, ate something icky, and righteous. If, however, it's labeled pure or gas, that indicates it's an actual compound, and it's not a solution. It has not been dissolved in water, and so then you would name it as a molecular compound. The kind of funky or weird thing about hydrogen compounds, however, is that for some reason they don't use any prefixes. So in the purple box, the example HCl, if it had an AQ behind it, we would call it hydrochloric acid. But if it said G for gas or pure, it would just be called hydrogen chloride. For some reason, they don't call it hydrogen monochloride. It's just hydrogen chloride, and those hydrogen compounds are a bit of an exception when it comes to naming compounds. If it's not an organic substance or an acid or hydrogen compound, then it's either going to be ionic or molecular. And to be ionic, we usually think of a metal and a nonmetal. However, if it starts with ammonium and H4+, that's our only cation that exists that's not made of a metal. So if it's got a plus and minus, then it's ionic, and we need to use crisscross. And when we name them, remember, there's no prefixes. If it's none of those compounds, the only possibility then is that it's molecular, and they can be recognized because they're made of 2 nonmetals, and they also contain those numerical prefixes as part of the names, things like mono, di, tri, tetra, etc. Also keep in mind, in the big picture, Dr. Hansen's going to provide some polyatomic ions, but you need to be able to manipulate the most common ion that ends in 8 into the other forms of ions in that series. For example, if he gave you sulfate, you should be able to, which is SO4 minus 2, you should be able to come up with sulfite, which has 1 fewer oxygen, and would be SO3 with a -2 charge. Remember, the central atom that the oxygens are attached to stays the same, and the charge stays the same. It's just the oxygens that change. There are some elements and symbols that Dr. Hansen is going to assume that you will know at this stage in the game, and I've listed them here on this slide. I've broken them into both metals and nonmetals. The metals include magnesium, silver, aluminum, copper, calcium, lithium, zinc, sodium, iron, and potassium. If Dr. Hansen would like you to write a compound with iron or copper, he will let you know if it's copper 1 or 2 or iron 2 or 3 by using a Roman numeral. The convenient thing about the metal ions or cations is that the name of the cation is identical to the name of the element. So if you have magnesium in a compound, the name of the ion would just be magnesium. For nonmetals, we also have a list. Those are the ones found on the right of the zigzag line. We have sulfur, bromine, nitrogen, phosphorus, fluorine, oxygen, chlorine, iodine, and carbon. And there's really two different times you may use these nonmetals and compounds. If it's at the beginning of a compound, remember then the element gets its normal name or the regular name that's on the periodic table. So if I had sulfur or an SO2 compound, that would be sulfur dioxide. However, if it was an ionic compound and I had MgS, then remember if the second part of the compound, if the anion is a single nonmetal, then its name changes to ide. And so in this case it would not be magnesium sulfur, it would be magnesium sulfide. So I have both the element name and then the ion name listed in parentheses with the IDE ending that you may need if that second part of the compound is a nonmetal. Some other miscellaneous nomenclature info to be aware of. We used ammonia in our first lab, and as a compound, ammonia has the formula NH3, and it shows up in a few places on the test. Be very careful to not confuse ammonia with ammonium. Ammonium is NH4 with a +1 charge, that's an ion. Ammonia is a molecular substance or compound made of nitrogen and hydrogen. Oxyanions, I touched on these earlier. You should be able to write other anions in a series when provided the most common ion in the series. I talked about sulfate and sulfite earlier. Another example, Dr. Hansen's going to provide for you the formula for nitrate, which is NO3. From that ion, you should be able to write nitrite, which would be NO2 - 1. Keep in mind, starting from that 8 anion, if it's an ite, you take away 1 oxygen. If it's hypo and ite, you take away 2 oxygens. And then going the other direction, if it's per and 8, then you add an oxygen to that original 8 ion. The other situation you may run into is when hydrogen has been added to the beginning of an ion. And an example of that is bicarbonate. Carbonate is one of the ions that you will be provided. Carbonate is CO3 with a -2 charge. If we have bicarbonate, or sometimes it's called hydrogen carbonate, imagine taking an H+ and putting that together with the original carbonate ion. We would then have HCO3, and if you add +1 and -2, you should get a -1 charge. So HCO3- would be bicarbonate or hydrogen carbonate. Another example of that, if we have sulfate, which is SO4 -2, then bisulfate, or it's sometimes called hydrogen sulfate, would be HSO4 with a -1 charge. So add the hydrogen, and remember H is always +1, and then you can add the charges together. And you can either add the name hydrogen to the front of the ion, but it's also very common to just use the prefix bi. That actually indicates that a hydrogen is present. In class, when we discussed ions in section 2.7, we talked about how to get the charges for different columns of elements on the periodic table. And Dr. Hansen will assume that you know how to get the charges for columns 1 and 2, as well as 3 through 8A. If there's an element in the transition metal area, he will provide the charge for you because they aren't as easy to predict. Keep in mind the key here in predicting the charges is that everything wants to obtain 8 valence electrons. And if you take a look at your test version of the periodic table, the one on the goldenrod paper, you'll notice not only is it missing names, but it's also missing valence electrons. And the way that I like to approach obtaining the charge, you can straight memorize them from left to right, But another convenient way to figure them out is to know what the valence electrons are on for each of these. And the way it works, column 1 has 1 valence electron, 2 has 2 valence electrons. I always just tell kids to count left to right. 1, 2, skip a few, 3, 4, 5, 6, 7, and 8. And so everything on this left side, which has 3 or fewer electrons, will lose. And so that's how we get the +1, +2, or +3 columns. Carbon family is a bit of an exception at 4, where it can lose or gain 4. And then everything to the right of carbon will gain electrons to become or to have 8 valence electrons. So we have -3, -2, and -1. The noble gases, of course, don't have any charge because they're already stable. And so that's a way to kind of know the charges based on an element's location in the periodic table. At this point, we should take a look at some practice examples. So I would recommend that you pause the video at this point and try to write the formula for the following substances. Keep in mind you will have these polyatomic ions to use on the test. So you should use the front side only of that goldenrod handout, the one that has the test version of the periodic table, as well as these polyatomic ions. Write your answers down, and once you've finished, go ahead and resume the video and check your work. Hopefully you've had a chance to try writing these formulas. Let's take a look. The first one, hydrofluoric acid, I see hydro and I see ic, which is the first acid naming rule, ide, hide, ric. So we are looking for fluoride. Now, fluoride is not on this ion list. Ides, ions that end in ide come from these non-metals in the top right. Remember, fluorine becomes fluoride, chlorine becomes chloride, sulfur becomes sulfide. So we're looking at fluorine with a -1 charge. Fluoride, with a -1 charge. If it's an acid, it has to begin with H, and in acids, H always have a +1 charge, so our overall answer is HF. If you wanted to be a little bit more complete, we could write AQ for to just show that it's an acid solution. Propane. There are 2 important pieces of information. When I look at this name, I see the prefix prop, which means that there are going to be 3 carbons. I also see ane, which tells me that it's an alkane. Now, as we discussed in class, you can memorize the general formulas for all the organic classes, or you can simply draw it and then add up how many of each element you have. So propane would be a 3-carbon chain with all single bonds. Keep in mind that all structural formulas require that carbon have 4 bonds around it. So you'd attach all the H's and come up with the formula C3H8. Magnesium chloride. Magnesium is an alkaline earth metal that would be +2, and chlorine is a halogen, which would have a -1 charge. So putting those 2 together, +2, -1, we would come up with the formula MgCl2. Sodium sulfate. Sodium is an alkali metal, which would have a +1 charge, and sulfate is on our ion list up here at the top, SO4 -2. Remember, for ionic compounds, if the charges don't add up to 0, we do need to crisscross, so Na2SO4. Zinc hydroxide. It tells us here zinc is actually a transition metal, and Dr. Hansen will provide the charge for those. Zinc is +2. Hydroxide is right here, OH -1. This is a polyatomic. It has more than one element, so when we crisscross, we need parentheses and a 2. ZnOH in parentheses 2. Iron 3 fluoride. Iron is a transition metal. The Roman numeral indicates to us that its charge is +3. Fluoride is F-1, and so we'd crisscross that to get FeF3. Ammonium oxide. Ammonium is a polyatomic ion. That's NH4 with a +1 charge. Oxide comes from oxygen, but when it's an ion, it picks up that IDE ending and is a -2 charge. So after the crisscross, it should be NH4, parentheses, 2O. Aluminum sulfide. Aluminum is in family 3A and has a +3 charge. Sulfide is not sulfate or sulfite. It doesn't have those ate or ite endings. Sulfide is the element sulfur, which is a chalcogen in family 6A, so its charge would be -2. After the crisscross, we will get Al2S3. Copper 2 nitrite. Now I want you to notice that this is ITE, not ATE. Nitrate is right up here, and it's got a -1 charge with 3 oxygens, but ite would be 1 fewer oxygen atom. So rather than, we're going to start with here our copper 2, and rather than NO3, we should be writing NO2. After the crisscross, we would get parentheses and a 2. Sulfur dioxide, S is sulfur, oxygen, and this prefix tells us it is molecular, and so we should have 2 oxygens. Whenever we see those prefixes, we don't have to worry about any sort of crisscross or charges. We let the prefixes help us determine what the subscript should be. Now, one overall observation I would like you to make, and this is on the nomenclature help sheet, anytime you have a binary compound, whether it's ionic or molecular, binary means it consists of only 2 elements. And if it can't be an acid, of course, that would, throw this generalization out the window, but a binary compound that's either ionic or molecular will always end in "ide." So if you take a look at some of the ones listed here, we have magnesium chloride, 2 elements, ends in "ide." This next one, sodium sulfate, does not. It's got 3 elements. Iron 3 fluoride ends in "ide," ammonium oxide. And so if it ends in "ide," well then of course here is hydroxide to mess with us. But if it ends in 2 elements, it has to end in "ide." There are other exceptions where it may also end in "ide," like hydroxide or cyanide or things like that. But if it has, it's one thing to just check your work when you're done. If it's only 2 elements, it must end in "ide." We'll finish with one more slide of examples. Here you are provided formulas and are asked to write the names. So, like the previous slide, you should pause the video and try these and then check your work. Okay, for the first one, this is an ionic compound. It starts with a cation. We need to name the 2 parts. And K is potassium. And then CO3 is carbonate. This next compound, I recognize that there are carbons and hydrogens, so it's an organic compound. It has 2 C's. I also notice this OH functional group at the end. And so starting with 2 carbons, the prefix or the name should start with Eth. And I want you to imagine the name ethane, with an E, but because it's an OH, we're going to drop the E and put an OL. That would be ethanol. The next one, FeSO4. We know it's iron, and we know SO4 is sulfate. The question is, which iron ion is it? And if you think about the charge on sulfate, it's -2. Now notice there's no parentheses or subscripts of any kind, and so that tells me to balance out the charge, this iron ion must also be +2. So we put a Roman numeral in parentheses. The next one is aluminum bromide. There's another example of one of those binary compounds where it must end in "ide," only 2 elements. Notice it's not aluminum tribromide because we don't use prefixes with ionic compounds. HBr, it's left a little bit ambiguous because it's not labeled. I would assume, since it has no label, that it is actually an acid, AQ. Br is a halogen, and bromine, but when it's in a compound, it becomes an ion and is called bromide. And so this one would be hydrobromic acid. If, however, it had been labeled HBr pure or gas, then remember we just name it as a hydrogen compound, and for some reason they never use prefixes with those, so rather than hydrogen monobromide, it's just hydrogen bromide. NO2, two nonmetals, so we should use prefixes. That would be nitrogen dioxide. It's fine to use a prefix on the second element, and it is fine to use one on the first element as well. It just can't ever be mono, so it's not mononitrogen dioxide, just nitrogen dioxide. Also notice when you write these molecular compounds, the first element has to end in its normal name, no IDE suffix, and the second one will always have IDE. The next one, the metal portion of the compound is lithium, and then notice this is SO3, not SO4. So sulfate is SO4, this would be lithium sulfite. And on the test, the ones that start with H will always clearly be labeled either AQ or pure. We're going to assume this one is an acid. SO4 is called sulfate, ate something icky, but rather than being sulfic, remember this one has those few extra letters in there, so we have sulfuric acid. The next one, lithium, and then carbonate is right here, but it looks like a hydrogen has been added to the beginning of that ion, so rather than lithium carbonate, you can either call it lithium hydrogen carbonate or lithium bicarbonate. Either one is fully acceptable. And the last one, calcium chloride. And again, a good thing to do when you're writing names is to take a look at the end and look for those binary compounds, the things made of just two elements, and make sure they end in "ide." So aluminum bromide, and of course it doesn't apply to acids, but when we're talking about ionic and moleculars, it does apply. Dioxide and chloride. So that's the end of our review. Please continue practicing and come and see Mrs. Hollenstein if you have questions. Good luck studying.